Welcome to this full tutorial about building this game from scratch with Bevy 0.7, an awesome ECS entity component system game engine for Rust. We'll start with our first ECS system to display our first rectangle. We'll learn how to use Asset Server to load our first texture for our player sprite. We'll place our player at the bottom and resize it. We'll do our first custom components to move our player with a keyboard resource. We spawn our lasers, spawn our enemies. We'll implement a collision with explosion that we will animate. We'll respawn the enemies. We'll control the enemies respawn and use our custom formation resource and component to make enemies move in formations. Okay, enough talking, let's start coding. So let's start with our cargo to ML. First, we're going to have the edition 2021. Make sure to have the latest one. Then we're going to use Bevy, the 0.7. Make sure to use the latest one as well. We're going to use our rand for the random numbers. And then finally, do not forget to put that. This is important for Bevy. Then we have our asset. We have our enemy. We have our explosion, which will be a grid 4x4, 16 sprite. We're going to have our laser for the player. We're going to have our laser for the enemies. And then we're going to have our player A, which is going to be our little Ferris. In our main.rs, the first step is to use the Bevy prelude. So we're going to do a use Bevy prelude star that will import most of the construct that you will need to use. And Bevy use the builder pattern. So we're going to do an app, which is a Bevy app, new, to start the builder pattern. And we're going to insert our first resource, which is going to be a clear color, which will be our background color. And we're going to have it relatively dark. Then we're going to insert another resource, which is going to be our window descriptor. In the window descriptor, we're going to use a .default because there's many properties that we can take the default from. And the things that we're going to override is going to be the title, and we're going to name it Rust Invaders. To string because it has to be on. And then we're going to have our custom width. That is very custom to this demo. Then the next line is a boilerplate, and we're going to do the add plugins, and we're going to give the default plugins. That will allow Bevy to work correctly with everything it needs. And finally, we're going to do a run. We're going to do a cargo run. It's going to compile everything, and then eventually it will display your first window. So that is the size that we gave. You can move it, and you can resize it. Okay, we can close that for now. Okay, so now we are ready to implement our first system. And a system is just a function. We are going to do our first system, which will be set up. And by convention, we are going to end our system function by system. This is just a convention. Now, as argument, the magic of Bevy is that Bevy will ingest the arguments that we are requesting by type. And usually, the first argument that you have is going to be a commands of type commands, come from the prelude, and that will allow you to put things or to remove things from the game scene. System does not return any value, and now inside it, we can use our command. The first entity we need to add to the scene is going to be a camera and a 2D, because that will be a 2D game. So we do a commands, spawn bundle. So that is a way to spawn an entity with a set of properties. And we're going to give our camera bundle that come from Bevy, and it's going to be an instance, a new 2D. That will be a 2D game. And now we are ready to add our rectangle to the scene, to the game. And for that, we use commands, spawn bundle, and we are going to use a sprite bundle with the default properties, and we're just going to override what we need. And for now, that will be our sprite, which will be a sprite type, and the sprite type takes some default as well. And we're going to have a color. On this one will be our RGB. We're going to do a little bit on the blue side with 0.75. And then we're going to give our size. And the way it works is you give a custom size, which is an option, which is going to be a vec2 of 150, 150. And those are F32. So now the way to wire the system into the game is we go back to our builder and we are going to add a startup system. And we are going to give the function name. And that is where Bevy magic will happen. It will take this type, create the appropriate structure, such as it can ingest the arguments. And this is a startup system because it's called once at the beginning. And then later, we're going to see how we can just add systems that will be called in every event loop. So now if in our terminal, we're going to do a cargo run with the Bevy dynamic trick, and that will display our first square. And now it's time to display our asset, our little player, little Ferris. And for that, we're going to stay organized. We're going to create a code section for our asset constant. And we're going to have a constant, which is a player sprite, which will be the name of the asset. And the way that Bevy works is by default, it will take the assets folder, and that is the file name that you are giving within the assets folder. So we're going to give player a01.png. And one thing that we're going to give is our player size, and that will become useful later. So we're going to do it now. And that will be just a tuple, f32 by f32. And we know the size of this PNG, which is 144 by 75. So that makes things later much simpler. So that is going to be the pattern we are going to use. Now that we have this constant, we can go back down. The first thing that we're going to do is in our setup system function, we're going to add an argument, which is going to be our asset server. And that will be a resource. And the way you do it is with a res type, which will take a generic, which will be our asset server. And that again is the magic of Bevy. If we look at these types, find the right resource and inject it as an argument of this function. So now when we spawn our bundle, resort to use a sprite. Sprite will be none by the default below. And we're going to override another property, which is going to be texture. And the way it works is we use our asset server. We load the player sprite, which is our file name. And the Bevy asset server will load it once, put it in memory, cache it, will actually return a handle of an image. We do our cargo run, Bevy dynamic, and that's it. We have our little Ferris at the center. Everything is always positioned at the center, so our sprite and everything is always at the middle. So here, because we didn't give any position, it's going to be dead center. So we're going to close our asset. And now what we actually want is to have our little window position over there for this tutorial. And so that's a good opportunity to learn how we can manage the position of the window. So what we're going to do is add another argument in our setup system, and that will be our windows, which will be a resource, and it has to be mutable. So we're going to do a resource mute of the windows. And now that we have that, we can go to the function and we can capture the window size, which we'll be using later. And the way it works is we do a let window, and we're going to use our windows resource, and we get a primary window, mutable, and we unwrap. Usually I don't like to use unwrap, but if we don't have a window, we are not up to code, and we have bigger issues. So that will be okay for this one. Now we're going to get our win width and height. This is a style I like, such as I have only one line for the assignment. Obviously you can have two lines, doesn't really matter. And then we can position our window. And that will be just for this tutorial, and we'll comment this out in the GitHub code. Those are the positions that works well for me. This is a IVEC2. You cannot do half pixel in this case, and that will be these window numbers. And now that we have that, I'm going to spare the terminal, but if I start it, it's going to display exactly there. So everything is looking pretty good. And we capture the size for later. So now what we want is a Ferris at the bottom. And because we have our window size, what we can do is at the bottom is going to be our minus windows height divided by 2. Because again, everything is at the center. And then in our sprite bundle, we have another property which will become a component of this entity. And that is a component transform. And for that, we have the default. And we have one property of the transform that will be a vec3. And we can position our sprite with 0. So it will be at the center horizontally. And then the y-axis is going to be the bottom where we're going to add half of the size of the player. And we're going to add a little bit of padding, 5 pixels. And then we're going to put 10. But because it's a 2D game, the 10 is actually the z-index. So we're going to have our player and enemy at 10, and our lasers will be at 1. So it will be behind the player and the enemies. And now if we run it, we see our little face at the bottom. So far, so good. Now we're going to have all our sprite half size. So for that, we're going to go back on top, have a constant, which will be sprite scale, which will be a 0.5. Then we go back down, and there's another property of transform, which will be scale. And you can scale the 3 axes, which will be sprite scale for the X, sprite scale for the Y, and then 1 for the z-index. We don't really need to scale it, obviously. If we run it, we see that we have our little face, but now we have a little bit too much gap. It's because we forgot to multiply the player size by the sprite scale. And now we have the face at the bottom. So far, so good. Okay, so the first thing we're going to do is move the spawn player logic into its own system. And first, we don't really want to have window in all our system that needs to have the size. So to do that, we're going to create our first resource, and that will be a good example to learn how to create a resource and to set it to the system. So our resource will be pub struct, win size, can be any struct we want, and then we're going to call it the width, f32, and the height. First, we're going to capture the win size, so that will be our win size, and we're going to get the values that we got above, win width and win height. And then we're going to call comments, and we're going to insert a resource. So now that will be available like other resources, and that will be our win size. Now if we run it, obviously everything is the same. And now that we have that, we can take our code for the player spawn, and we're going to create another system, which will be a player spawn system. We're going to follow the convention. The arguments will be our comments, because we need to spawn the player. And then we're going to have our asset servers, which we need to load the sprite. And now, rather to have the window resource, we're just going to have our win size. And that will be our resource. And inside it, we're going to have our win size type. That is the way it works. Now, inside the body of the function, we're just going to paste what we have. And rather to have win underscore h, we're going to have win size dot h. And then we need to take the player spawn system, go back to our builder, and we're going to do an add startup system. But here's a little trick. We need this system to be called after the setup. So it's still a startup system. It's called only once at the beginning, but we want it after the setup system. So to do that, we're going to have add startup system to stage. And then you put an enum variant here to say that you want it post startup. And then we're giving our function. There's many ways to do these kind of things, but here this one works pretty well here. Now, if we run it, we still have exactly the same, but our code is a little bit better. So now another thing that we want to do as well as another custom resource is all of the sprite, rather to have asset server everywhere, we're going to have our game textures, which will be our custom resource. And for now, there will just be a player. And the asset server returns a handle of image. So now that we have this game texture, we're going to go down into our setup system. And after the win size resource, we're going to add the game textures resource. We're going to create it. So far, there is only the player. And then later, we'll have all our assets this way. So exactly the same, player sprite. Then we don't forget to insert it with insert resource and our instance of game textures. So that would be a singleton in a way. It's only one for the whole game all the time, which is what we want anyway. Then we go to our player spawn system, and rather to have our asset server, now we can have our game textures, which will be a resource. Doesn't have to be mute. So it's very important in Bevy, when you don't need mute, don't get mute, such as Bevy can optimize behind the scene. Now we take our game textures and rather to call our asset server, which we don't have. Now we're going to do a game texture player, and then we have to clone the handle. And the handle is very small. It's just like a number ID. So now if we run, obviously everything works the same, but now things are much cleaner. So now we want to componentize a little bit our code, such as we move all of the player logic to their own module. And Bevy has a nice concept. So if we go back up, and it has a concept of plugins. So first, a plugin, usually you put it in its own module. So we're going to create a module, which is going to be a module player. Create the file, and then we're going to take the player spawn system and everything that relates to player, and we're going to go to our player files, paste it over there. We're going to use our Bevy prelude, and we're going to import everything that needs to be imported from main. And now the way it works is in Bevy, you can create your own plugin, and a plugin is just a unit struct. And then you implement plugin trait for your plugin struct. And it has one method, which is build, that takes the application builder, obviously as mutable. And then inside it, we're just calling the app as we did in main. And so we're going to add our startup system to stage. And then we're going to do a post startup. And then we're just putting our function there. Then we go back to our main. And then we can remove the player spawn system. And now we can go to our app builder and add a plugin without S. And that will be our player plugin that we import. We remove the line that we have below. We don't need it anymore because it's part of the player plugin now. And if we run it, we get the same thing. Okay, enough about the refactoring. We're going to add some cool functionality now. And so first we're going to add the keyboard movement. And for that, we are going to create our first Bevy components. And so we're going to create a module components where we're going to put all our components. Obviously that can be anywhere, can be in the same file, it doesn't really matter. And then in the component, we're going to use the Bevy prelude, but just the component in this file. We don't need more. Then we're going to add the command components, which will be components that will be shared across entities. And we're going to have the velocity. And we're going to use velocity to move the player and the lasers. And there's two properties, and that is the X and the Y. And then to make it a component, in Bevy 0.6 and 0.7, you need to make sure that you have a derive component. And then we're going to have our player components, which is just going to be for our player. And for now, it's just going to be a unit struct. And we'll just use that as a marker. And we're going to see later why that is very useful. So now we go back to our player.rs. And here we can see that we have our player spawn system. And so what happened is when we did a commands spawn bundle and we give a sprite bundle, actually all of the first level properties of the sprite bundles are actually components. And the way that we can add more is by chaining insert. And we're going to give our component, which is just going to be our player component that we created before. And then we're going to insert our velocity component. And so far, we're going to hardcode the velocity to move to the right. So we're going to insert velocity. The X will be 1 and the Y will be 0. Press save, a little bit of reformatting. And now make sure that we import our velocity. And so the entity will have all of the first level properties of sprite bundle as components, so texture and transform, and all of the other one, which probably will be known. And then as well our custom components, which will be player and velocity. And we're going to see later how we are going to query and mutate some of them. So now if we go down, we can make our own player movement system, which will be responsible of moving our player. And now that is the second big concept of Bevy. And that will take a type, which is called query. And as a generic, there's two parts. The first one is a component you want to read the value of, or you want to mutate. So here we want to read velocity. We don't need to mutate it, but we want to write on the transform to move our player. And we want to make sure that we only have the player. So for that, as a second part of the generic, we can do a with player. That is almost like a SQL where. So now we are ready to do our for loop to iterate through the entities. In this case, we know that we have only one player, so there's another way that we're going to see later. But right now, we're going to see this way, which is very generic. So we're going to do a for loop. First, it will be the tuple of the data that we have over there. So it will be the velocity and the mutable transform that we want to mute because it's a movement system. And then for the iterator, we do the query, and then we have itermute because we're going to mute one of the property. Then we're going to extract our translation from the transform as a mutable reference. And then we're going to just change the value of our translation x by the velocity of x and translation y by the velocity of y. Very simple. And those will be the values that we have there. Now we take this player movement system, we're going to go back up and we're going to add it as a system, but that won't be a startup system because we want it to be called in every event loop. So very similar, we do the add system and we give our function. And now if you click on run, you are going to see the little Ferris moving to the right. Very basic, but at least we got it right. Now we're going to put one thing right now into some constant, and that is the time step and the speed. So we go back to our main, and we're going to add a game constant section, and we're going to give our time step, and that will be our 60 frames per second. And then our base speed will be 500. So now we're going to go back to our player module, and rather to just have the velocity, we're going to multiply by time step and multiply by base speed. Make sure to import those two. And now if we run it again, we see that it goes much faster. And that will make more sense later when we'll have the keyboards and the lasers and so on. So obviously we don't want that. We want to move with the keyboard. So initially the velocity should be 0. So we're going to go to our spawn entity and we're going to set x to 0. And now what we want to create is another system, which will be our player keyboard event system. And that is a magic. It's decoupled from the movement system. It's just something that takes the keyboard and changes the velocity. And the first argument is going to be our keyboard, and that will be a resource of the input key code. And then we're going to have our query, which we're going to do the query of the velocity. And in this case, we don't need a tuple because we just need one. So we're just going to change the velocity and only the velocity of the player. And that is the magic of Bevy. The first system, the keyboard event system, is going to change the velocity. And then you have another system that will make the movement of any objects that can have velocity. And later, we're going to generalize the player movement system to a movable system to move the lasers and the player as well. And so now, we're just going to get that as a data. We don't need a tuple. And so now we're going to get the second way, the right way, because we know that we have only one player. So we're going to do a let OK of our velocity. And we can use the query get single mute, because again, we need to mute the security. So that is a way when you know that you have only one entity for this query, you can use that. And then inside this if statement, we're going to change our velocity x on the keyboard pressed value. So if the press is left, then we're going to say it's -1. If the press is right, then we're going to make it 1, go to the right. And then otherwise, because that will be called on every event loop, we're going to say it's 0. And then we take this player keyboard event system and we're going to add it as a system. Not as a startup system, as a system, because it has to be called in every event loop. And now if we run the application, if we press our keyboards, our little Ferris is moving. Very simple once we get the thing right. And that is the beauty of Bevy. Okay, so now is a good time to do our player lasers. So let's go back to our main. In our game textures, we are going to add our player laser, and that will also be a handle of image. Then in our asset constant, we are going to add our player laser sprite, and that is the name that we had under the assets folder. And then our player laser size, which will be 9 and 54. Now we go back down, and obviously we need to go to our setup system. And in the game texture, we're going to add our player laser. Now if we go back to player, we're going to add a new system, and that will be a player fire system. And as argument, it will need to spawn something inside the scene. So we're going to use commands. We're going to use our keyboard resource, and then our game textures, such as we can spawn the new laser. And then we're going to have our query to know where the player is. So we need to do the transform. We don't need to write on it. And that will be a with player. Now we're going to do our if let OK to do the query get single. We don't need mutable. and we don't have it on top anyway. And we're going to do keyboard just pressed, so meaning that it's just been pressed now. And we're going to say if the spacebar is just pressed, we're going to extract the XY from the player transform that we have above. And then we're going to spawn our sprite bundle, which will be with a texture of player laser. We'll do the clone, and we're going to put the translation at the same position as our player. And so that will be from the center. And then we don't forget to scale, because everything will be scaled half, and that is a constant of sprite scale. And obviously we don't need to scale the z-index. Now if we go back on top, we're going to add a system, and that will be our player fire system. We run the application, we can move it with the keyboard, and when we press space, we start firing. Obviously the laser is not moving, but actually they are spawning pretty well. Okay, let's make them move now. So what we can do is make our player movement system a little bit more generic. So in our fire system, we want to use the velocity as well. So we can go back to our spawn system, and then we're going to take the same component, which is a common component that we spawn with our player. We can actually spawn the velocity for our laser entity, just like that. And now, because we want it to go up, so we're going to put the Y at 1. Now, if we go back to our components, we're going to create a common component, which is going to be movable. So anything movable will have this component. And we're going to have one property, and that is going to be auto despawn. A player won't despawn when it goes out of the screen, but a laser will, otherwise we're going to have a memory leak. We don't forget to make that as a component. And now we can take the movable, go back to our player, and for our fire system, when we spawn the laser, we're going to add movable, and we're going to do the auto despawn. Then we make sure that we take that, and we need to add it as well to our player. But in this case, auto despawn will be false. Now, if we go back on top, we're going to remove our player movement system because we want to have a generic one for everybody. So we're going to cut the function, go back to our main, because that will be a common system for everybody. And rather to be called player movement system is going to be movable system. And then we're going to add the commands for later, because we're going to have to despawn the entities when it goes out. And then to know if it goes out, we need to obviously add the window size, and this is where we have our window size resource. And then on the query side, we're going to add another component, special one, which is entity. And that is a Bevy main ID, in a way, of the entity. So that is how you refer to an entity in the Bevy space. And then we want also to read the movable component for this entity to make sure that we get the auto despawn flag. And now, because we have the movable as part of the query, obviously do not want only player, but we don't even need to have a with, because the data is sufficient to describe what we want. So we need to complete our tuple, so that the first one will be the entity, and then the second one will be the movable. Make sure we import everything. We'll do the auto despawn later, and for now, we're going to take our movable system, go back to main, and just add a system, movable system. Press save, start moving the player, and then that's it. Our lasers is working. Super cool. And we use the same system for both. So once you get the thing in the right place with Bevy, things goes very quickly. So now we have a problem. We think that the laser disappear, but they don't. So when they reach the top, they goes forever. But we want them to despawn when they reach the top. So we already had our component for that. We just need to implement the logic. So we go back down into our movable system, and very simple. We say if movable is auto despawn, then we despawn with out of screen. We're just going to have a quick margin. Hard coding probably needs to be by the sprite size, but this one is going to be simple for now. And then we're saying that if the translation of the movable is above the window size plus the margin, or below, and then just for completeness, we're also going to do that for the x-axis. So then we're going to print it to make sure that it works. So we're going to despawn, and then we're going to give the entity as a debug. And then we're going to call commands entity, the entity value that we extracted in our for loop, and then we call despawn. And now if we make the terminal a little bit bigger, we're going to run it, and then as the laser goes out, we see the print. Okay, so now that is starting to be pretty cool. We're going to remove the println. So now what we want is the two lasers on each clause. So for that, we're going to go back to our player module. And in our player file system, we are going to first compute the offset, which is going to be the X offset, which will be the player size divided by 2, multiplied by the sprite scale, and then the value that works well, which should probably be a ratio, but it's 5. So that will place it just under the clause. And now we can take the X offset and add it in our translation. Now if we run the game, we can see that it shoots from one clause. Now I start a little bit below the clause. So for that, we're going to hard code a Y offset. That will be the same for both anyway. And that 15 works pretty well. And now it works much better. But obviously we have only one laser, we want 2. And for that, we're going to use Rust closure. So we're going to take this code and we're going to create a closure, spawn laser, and it will take the offset. That will be our code. Press save. Obviously that doesn't call anything. So we need to call it twice. One with a positive offset and one with the negative offset. And then that's it. That's pretty cool. Okay, time to do our enemies. So we're going to go back to main, and at the top, we're going to create a mod enemy. We create the file, and before we jump to it, we're going to have to update our asset constant. So enemy sprite, enemy size, and we're going to do the laser as well, because we don't have to do that too many times. And then obviously we need to update our resource, our game texture, enemy and enemy laser. We go back to our setup system, and then we're going to create our enemy and enemy lasers, exactly as the player. Now we're going to go to our enemy, use Bevy, the prelude. We're going to also include the correct game textures. That will be our enemy plugin. And then we're going to implement the plugin for enemy plugin. And then the first system will be the enemy spawn system. That will take a command, the game texture. And we're just going to spawn the sprite bundle, give our texture that we clone, and in our build method, we're going to add a startup system. We're also going to put it to stage post startup, because later we're going to get the window size and the enemy spawn system. Now we take the enemy plugin, go back to main, and inside main, we're going to add the plugin, enemy plugin. We import it, click on run, and then that's it. Obviously kind of ghosty, but so far so good. So we're going to want to size this one. So we go back to our enemy, and in the transform, we're going to put our scale. Now it looks much better, still ghost. And now to make it a little bit more fun, we want to have it a little bit random in some random places. So for that, we need to have our window size, so our window size resource. And then we're going to compute the XY. So we're going to get the random generator, and we're just going to have the span, which is basically the area that equals spawn. And we're going to do the same thing with the height. And then we're going to say that X will be a range of the W span, and Y will be the same for the hash span. And then in our transform, we're going to have our translation, vector 3, and we're going to give our XY that we have above. And again, we have a 10, that will be our z-index, which obviously we do not need to scale. And now if we click on run, we have it in a random place. And if we restart it, we have it in another random place. So far, so good. So now what we want to do is a collision between the laser and the enemy. And to do that, we need to create some new components. So we're going to go to our components module, and we're going to create a couple of common components. The first one is going to be laser, which we're going to attach to the player laser or the enemy laser later. And then the second component that we're going to do, because we're going to have to compute the collision, is going to be a sprite size. And there's different ways to do that, but this one is a simple one. That will be a component as well. And then we're going to implement a convenient from the tuple f32, f32, which is what we had in the constant for this sprite size. And that will return just a vec2 of this size. And we'll see how we're going to use that later. Then in the player components, we're going to add another unit struct component from player, and that will be a marker struct. And we will add the from player to anything that comes from a player. And then we are going to mirror these two components for the enemy. So we're going to have our enemy component and then our from enemy component. Then we go back to our enemy module. And when we spawn our enemy, we're going to make sure to add the insert enemy. Now in our player file system, we also need to add the from player. And we're going to add our sprite size. In the player spawn, we're also going to add our sprite size. And then if we go back to our enemy, same thing here, we're going to add our sprite size, such as everything has a sprite size, and then we can compute the collision. Now if we go back to our main, we're going to add the player laser hit enemy system. That will take a command because we're going to have to despawn the laser and the enemy. Then we're going to have our laser query. And on the data side, we want to have a special component, which is entity, which will allow us to have the handle on the entity. We're going to see how we're going to use it later. Then the transform, the sprite size, and then as a condition, we want it with the component laser, as well as, and we're putting that in the tuple, with from player. And then on the enemy query, we're going to have our query, and on the data side, it's going to be similar. Entity, transform, the sprite size of the enemy, and then the only thing that we need in this case is with enemy. So when you need only one, you don't need to put it in a tuple. We make sure we import everything, and then we're going to iterate through our lasers, and on the element side, we're going to have our laser, our transform, and our sprite size. And then we're just doing a laser query, iter. So again, here we don't need mute. So when you don't need mute, make sure to not use mute. And then the first thing we're going to do is a laser scale that we'll use later. And for that, we're just going to do a vec2 from laser. Make sure to import this trait to have the XY. And now that we have that, we're going to iterate through the enemies. So very similar. We have the enemy entity, the enemy transform, and the enemy size. And same thing, query, iter. So far so good. And we're going to get the enemy scale, which is going to be similar to what we have above. And then we're going to determine if we have a collision. And we're going to have a let collision, and we're going to use a function from Bevy, which is a simple kind of collide function. In your game, you might use physics engine, but for this one, if you have a simple 2D games like that, that will be okay. And the way it works is you give your first object position, your first object size, that we're going to multiply by the scale. That's why we had the laser scale above. And then it takes another pair for the other object, which will be in our case, enemy. That will return an option of collision. So then the thing that we need to do is fix the typo, and then we're going to perform the collision logic. So we do a if let sum equal collision. We don't really care about the data of the collision. We just care to know if there is one. And then we're going to remove the enemy. And the way you do that is you do the commands entity, the enemy entity, and then we are going to do a despawn. And then we're going to remove the laser as well. And so doing exactly the same thing, commands entity, laser entity, despawn. There's some corner cases that we're going to take care later. But for now, this is the foundation. So then we go back up. We're going to take the system. We're going to register it as another system to be executed in every event loop. Now we need to go to our player, and we are going to add in the player file. I think we forgot. So we added the from player, but we didn't add the laser. So we're going to make sure that we add the laser to this component when we fire. Otherwise, the query that we had in our laser hit system wouldn't be met. So now that we have that, we can go back to our main, and we're going to run it. We shoot nothing. We aim, and we shoot our enemy, and it disappears. So obviously no explosion, but it's already starting to look pretty good. So now what we want is to do our explosion. And for that, we're going to use our explosion sprite sheet that is in our assets folder. And that is this grid, which is a 4x4. So first we're going to create the asset. If we go back to our main, we're going to go to our asset constants, and then we're going to add our explosion PNG. And if we go down, we're going to go to the resources, and now we're going to add another game textures, which is going to be our explosion, and that will be a handle of texture atlas. That is a way that sprite grids are stored, such as we can navigate through them. And now in our setup system, we need something else. We're going to need a texture atlases that will allow us to load those kind of resources. That will be a res mute of asset texture atlas. So now if we go back to our game texture, there's a couple of more of boilerplate code. We're going to create the explosion texture atlas. And for that, we first create our texture handle. So that is as we are loading any sprites. And then we're going to create our texture atlas. And we're going to give our texture handle and then a vector that describes the grid. So it's 64 by 64. So each cell are 64 by 64. And we have a 4x4 grid. That is the way you do it. And finally, we're going to create our explosion, which will be our texture atlases. And we are adding the texture atlas that we have above. That will return this handle of this texture atlas. And now that we have that, we can put it in our game's texture, and we have that loaded. So now we're going to go back into our components, and now we're going to create our explosion components. The first one is going to be our explosion, like we have player and enemy, just a marker component. And then we're going to have our explosion to spawn. And that is going to be a tuple struct with one member, which is just going to be the position of where the explosion needs to spawn. And that is a little interaction between triggering the explosion and executing the animation. That is very convenient because we can use that and put that anywhere we want to have an explosion without having to worry about how to display the explosion. And then the last component we're going to do is going to be our explosion timer, which is a wrapper on top of Bevy timer. So Bevy has a core timer. So when you animate between the 16 sprite cell, you want to wait a little bit before you go to next one. And that is what allows you to do this wait. And for explosion, we can hardcode the speed of the explosion animation. So we're going to implement a default implementation for explosion timer. And that will just return the tuple of self with a timer from seconds. And we're saying that is every 50 milliseconds, it will reset the timer. So then we'll be able to tick it. And every time it goes to 0, it will reset to 50 milliseconds. And so that if you want to do animation about every 50 milliseconds, that is a great way. That is going to be wrapping this timer. So now if we go back to our main, and we're going to go to our player laser hit enemy system, and when we're going to have a collision, we're going to spawn the explosion to spawn entity. For that, we're going to do commands, spawn. We're not spawning a sprite bundle of anything. And then the only thing that this entity will have is our custom component, explosion to spawn, with a position of where it needs to spawn. So here will be the position of the enemy. Now, if we run the game, we won't do anything special because when the enemy despawn and the laser despawn, we're just spawning this entity that just had a position. So there's no explosion yet. So what we need to do is we're going to go down and we're going to create our explosion to spawn system. And that is going to be the system that is going to take the explosion to spawn component and spawn a real sprite bundle. So we're going to take the commands, the game's textures, because we're going to have to spawn our sprite, our texture atlas that we created before. And then we're going to have the query, and we're going to query the entity, and then the explosion to spawn component, which will have the position. So in this case, we don't need to do a where clause, a with, because by the data, we will only get the data that has an explosion to spawn. So that is enough. And then we're going to do the for loop, can have multiple explosions at the same time, obviously. So we're going to do a for explosion, spawn entity, and then the explosion to spawn. So will be the entity and then the structure with the position. That will be on the query iter. We don't need to mutate anything. And we're going to spawn the explosion sprite. So for that, we call commands like the rest. We do a spawn bundle. And now, rather to have a simple sprite bundle, we're going to have a sprite sheet bundle. And we'll have the default. And now, rather to have the texture, we're going to have texture atlas. And that will be our game textures, the explosion, and we do the clone. And now, like any other sprite bundle, we'll have our transform that have the translation for the position. And that will be exactly the same translation that our explosion to spawn. And now we're going to insert our marker component, which is explosion, to let know the system that that is an explosion. And then we're going to create our timer for this explosion. So that is what we did before, such as we can animate the explosion. And then finally, we're going to despawn the explosion to spawn. So we make sure that we don't keep adding to it. We need to clean after ourselves. And that will be the commands entity, the explosion to spawn entity, and the despawn. So now that we got that right, we are going to do our animation system now. So that will be the explosion animation system. We'll take the mute commands, because at the end, we're going to have to remove the explosion. We're going to get the time, and that is a resource to know which time it is related to the previous frame. And then we're going to do our query to query all of the explosions. So not the explosion to spawn anymore. We're going to query the explosion sprite bundles that we just did. So we're going to want to have the entity, the mutable explosion timer, because we're going to have to mute it as time goes. And then the texture atlas sprite, which is what we created above. And that will allow us to iterate through the sprite. And now we make sure that we're querying things for explosion. Now, because we only have explosions that have texture atlas sprite, that wouldn't have been required in this case, but we're going to keep it there. Then we're going to do our for. So we get the entity, timer, the sprite. We're going to iterate through all of the explosion, sprite bundle, have to be mutable. So we have our explosion timer, which has a Bevy timer inside, and we're just going to tick it with a time delta. That's the deltas in the last frame. And when it reaches 0 or below, timer.0.finished. So that is when it reaches 0 or below. And then we're going to increase our index by 1, the next sprite. That will move to next sprite cell in our sprite sheet. And then if the sprite index is greater than the explosion length, and that we haven't created, we're going to create it right now. We're going to do a commands entity, and we're going to despawn the explosion. Now let's create the explosion length, and we're going to go back up. And in our asset constant, where we have our explosion, we're going to add this constant, and that is going to be 16. We close that. And now if we go back at the bottom, and now we actually have a compile error. We're actually modifying the sprite, but we forgot when we're doing the query to require it as a mutable. So we just need to do a @mute, press save, and that goes away. So now we have that. We're going to close all this code, take the functions, go back up, and now we're going to add this to system to our application. Okay, click on run, and then boom, we have the explosion. So that's pretty cool, but we do want to respawn the enemy as we are killing them. So for that, we're going to go back to our enemy module, our enemy plugin. Inside the plugin, in our build, we're going to just add it as a system. So we're going to remove the post startup, and we're going to see what that is doing. Now, if we run our application, we can see that we're spawning a lot of things, and it's actually working pretty well. However, we can see that we're spawning a lot of enemy. We can start shooting them, and we are actually seeing that we have a little corner case bug where sometimes it's trying to remove multiple times the same entity. And so that is a warning that we're getting here. So first, let's try to understand where the mistake is. So it's probably when we despawn in our laser system. What's happening is sometimes two lasers can hit at the same time, and then it will remove the enemy or the laser multiple times. So the way we're going to fix that is we go back up, and we're going to do some bookkeeping. So it's going to be simple for this one. We're going to have a despawn entities, and that is going to be a hash set. And that will be a system hash set. It doesn't have to be a Bevy one. And that is going to take the entity as type. At the beginning, obviously, we create a new one. And now that, because every entity is global to the system, entity ID, so what we can do is when we're removing an enemy, we're going to add it to this set. When we're removing the laser, we're going to add the entity to this set. And now if we go back on top, we're going to do some guards and to say at the laser level, if the laser entity is contained, then we're just going to continue and move to the next one. And then in the for enemy loop, we're going to check that the despawn doesn't contain the enemy entity as well as doesn't contain the laser entity, because we can be in a case where we still loop through the laser. So that is going to be this. And in this case, we do the continue as well. And now we're going to run it again. We're going to shoot like crazy and we don't get a warning anymore. So this one has been closed. Okay, sometimes silly stuff is good stuff. Let's close that. Now, obviously, we don't want to respond as fast. And so what we're going to do is we go back up and we're going to have a constant, which will be the maximum enemy on stage. And right now, we're just going to put 2. And that will be better for debugging. And then we need to keep a resource. So that is strategies that we're going to have. We can also query the enemies all the time. That would work. But right now, we're going to have a resource that would be our enemy count. And that will just be a tuple of U32. And then in our setup system, we're going to add this resource and just have 0, obviously. And in our player hit enemy system, we are going to add this resource as mutable because we are going to change it, decrement it every time we hit an enemy. And in the for loop, we are going to add when we remove the enemy, just after, we're going to decrease the number of enemy on stage. Now, obviously, we need to change our enemy. So if we go to the enemy module, we are going to do our enemy spawn system and we are going to add this resource again. So that will be our enemy count and it has to be mutable as well. And then every time we spawn enemy after, we are going to update this resource by just increasing the count. Now that we have that set up, we can take all of this code in the enemy spawn and make sure that we spawn it only if enemy count is lesser than enemy max. Then we add our code back, press save, and now we have only 2 enemies at a time that they are respawning back to back. Starting to look pretty good. So one little fine tuning is we don't want the enemy to spawn just after. We want to have a little delay. So the way you do that in Bevy is you go back and when you add a system, what you can do is add a system set. And in this case, you create it like that, system set new, and you give your run criteria, which is going to run before the system to decide if the system is going to get called or not for every frame loop. So in this case, we're going to be a very simple one. We want the run criteria to be a fixed time step. That is a Bevy criteria. And then we're going to have a step of 1. That will be every second. And to tell which system to run, we just do with system and we give our system function back. Press run. Now we see that they're appearing slower. And if we shoot them, it's going to take a little while for them to reappear. Okay, so let's close that. Now what we want is the enemy to start firing. So we're going to add our system, enemy fire system. Very simple. We're going to go down, add it. It's going to be our commands, our game textures. So that is going to be the new lasers. And we're going to have our enemy query because we want the enemy to fire. And they are going to fire all at the same time. In this example, obviously, you can fine-tune that. And the only thing that we need to have is a transform position to know where the laser starts. And then that will be a with enemy. Then inside the function, we have our for loop for all of the enemies. We are going to get our transform. We just need the transform, so we do not need to have a tuple. And then we're going to have enemy query iter. Inside it, we're going to spawn the enemy laser sprite. We do the command. We spawn the bundle, sprite bundle. We have the default. We give our texture. And that is the enemy laser texture that we had before. So everything is set up. And then we do our transform to tell where the laser will spawn from with translation. So that will be the position of the enemy. We're going to offset it a little bit, the Y. And again, the z-index, we put it at 0. And then we're going to do the scale. That will be our sprite scale. And the z-index, we don't. Now let's define the x and y. Very simple. The x and y is going to be the transformation translate x and y. And then we're going to do an insert laser. We do our insert sprite size for the collision later. And then we're going to do our insert from enemy to know which laser it is. And finally, we don't forget our movable that we did at the beginning, because we're going to use a movable system and we want to auto despawn. So that is the reason why we had the auto despawn also at the bottom, because obviously the enemy lasers will fall down. And finally, to make them fall down, we have the velocity component with x at 0 and the y at -1 because it's going to fall down. Now we're going to import everything. We run it and then they're shooting, but a couple of issues, little too hard, and moreover, they are in the opposite mode. So now let's control a little bit the fire. And for that, we're going to learn how to do our custom system criteria. So it's going to be an enemy fire criteria. And that is just a function that will return an enum that is a should run, yes or no. And for now, for this one, we're just going to fire random. Obviously, you can have very fancy. And then it's going to just use the random generator. And we're going to do a random on every 60 frames per second. So it's basically more or less 1 per second. And then if it is, we return should run yes. And if it's not, we return should run no. Now we're going to take this criteria, and the way that we wire it is very similar to what we had with the system set. So what we're going to do is add system set, and rather to pass directly the fire system, we're creating our system set with the new criteria that we just created. We just give the function, and we add with our system, which is the enemy fire system. Press save, click run, and now we have our enemies that fires a little bit upside down, but still. So what we want is to rotate the laser. So it's super easy. We go back to our enemy fire system, and we have another property of transform, which is rotation. We use a struct, which is quad, and that is going to be a from rotation, and that will do all the math for us, and we just rotate it with pi. And now click on run, and that fires correctly. By the way, when I say click on run is, command line, yes, that don't do the run debug. Okay, so that is pretty cool, but what we would like to have is a collision for the enemy lasers. So we're going to go to our main, and we could probably reuse the same system, but we're going to create another one, which is going to be enemy laser hit player. And that is with our commands, with our laser query, same data as before, except that now the query is going to be with laser from enemy. And then we're going to have our player query, and that will be our query for the player with player. Very simple. We import everything, and then in the function, we're going to have our if let OK, because we know that we have only one player at a time. So we have our data, the player entity, player transform, and the sprite size from our player query, single. We don't need to have the mute, and we're going to get the scale as before for the player. And then we're going to do our for loop on all of the enemy lasers. So laser entity, laser transform, and laser size. And that will be our laser query iter. Then we're going to do the same scale for the enemy laser. And then we're going to determine if we have a collision. So if collision, and we do exactly the same thing, the laser translation, laser size with a scale. And now we're going to perform the collision. It's going to be a little bit different than before because it's actually simpler. And again, the collide return an option. So if we have a collision, what we're going to do is remove the player. So far, so good. So commands entity, player entity, despawn. And then we're going to remove the laser as well. And then we're going to do the commands like that. And then we're going to spawn our explosion to spawn. And we don't have to worry about having game textures or sprite bundles here. Everything is taken care of. So the explosion will be at the position of the player transformation translation. So once the player is hit, now we can break the whole loop, such as we don't have to continue anything. So that's why we don't need to do the bookkeeping. So it's much simpler in this case. Now, obviously, we go back up, we go to main. We're going to add the system, press save. We shoot, we win. We're hit, and we lose. And that's it. Now, obviously, we want to respawn the player as well. And so for that, we're going to go back up, and we're going to do similar strategies that we had for our enemy. We're going to create a player state that will be a struct with two properties, the on, if the player is on stage or not, and then the last shot. And by convention, we're going to say that if it's -1, if not shot. And again, there's a lot of different strategy here. It doesn't really matter, but this is just an example. So now we're going to implement the default. It's always a good practice to implement default. And we're going to have the on, which is false, and the last shot, which is -1. And we're also going to implement a couple of methods, such as we can keep things clean and out of the application code, which is going to be our shot method, which will mute and will take the time as a F64. So that is when we get shot, that will get called. And we're going to do the self on false and self on last shot, and we capture the time. And then we're going to have the symmetrical function, which is going to be spawn, and that is just a mute self. Doesn't have to have any data in this context, and that will just put back self on to true and self last shot to -1, as we have above. Now, if we go back up, we're also going to go to our game constant, and we're going to create player respawn delay. That will be kind of a delay of how long the player will respond to. We'll set it to 2 for now. And now, if we go back to our enemy laser hit player, we're going to have our mute player state. That will be a resource mute of player state, obviously. And we're going to have the time as well, which we need. And now when we have a hit, when we remove the player, we're going to update the player state with shot, and we give the time. And the time will be a time second since startup. So that will be the frame of reference. And now we can change our player spawn. So we go back to our player module, and inside our plugin, rather to call the player spawn system at startup, we're going to call it in the event loop, but we're going to still use a set, and we're going to see why. So first we're going to remove the post startup, then we're going to create a new system set, and the criteria is going to be very simple, but it's going to be a time-based, such as rather to do the check 60 times a second, we'll do it twice a second. It's not needed, it's just an example here of how we can do a little bit of optimization. And then we're going to add our with system and our player spawn. We make sure to load the fixed time step. Then we go to our player spawn system, and obviously we're going to inject the player state, which will be a resource mute because it has to be muted. Then we have our time, which will be a resource time. Make sure to import the player state. And then in the body of the function, we're going to get the now time from the startup, and we're going to get the last shot. And our condition to decide if we need to spawn a new player or not is going to be a if the player is not on. If it's on, we don't need to do anything. And either the last shot is -1, which is at the beginning, or that the now is past the last shot plus the delay. And obviously that could be much more complex. You can create a custom criteria to do these kind of things as well. And then in the if statement, we're going to take all our code, copy it, and then put it there. And then we don't forget at the end to update our player state to say that we just spawned. Such a state will be updated. And then finally, we go back up, and then we make sure to insert the resource, which is our player state default. Press save. We have the game. We shoot, we win. We get shot, we lose. But we are back. And that's it. Starting to get pretty cool. So obviously what we need to do is make the enemy move. So for that, we're going to go back to our enemy module, and we're going to add a system, which is going to be enemy movement system. We are not going to use a movable system because we want to be a little bit more advanced for enemies. So we're going to create our own custom system. So we have our function, enemy movement system. We take the query, which is going to take the mutable transform for all of the enemy. Then we're going to iterate through all of the transforms. And that has to be an itermute because we're going to move them. And for now, it's going to be really silly. So first, we're extracting the translation. We're just going to do a slow-mo move for now for X and for Y as well. Now we forgot to have the query mutable on top versus always making sure we get things right. Press save, click on run, and now we have the enemies that goes away. Pretty cool. So that's not great, but that's a start. Okay, so let's close this one. We want to be a little bit more fancier at this point. So what we're going to do is make them turn in an ellipse. And for now, the ellipse will be guided by time only. So we're going to have a time argument, a time resource. We grab the now, which will be a f64 by default, but we would like to be f32. So we're going to do as f32. And then in the for loop, we're going to get the current position of the enemy. And then we're going to compute the maximum distance. And that is important when you turn into an ellipse. You don't want to overshoot, otherwise kind of jingle around. So we're going to have the max distance, and that will be our time step multiplied by the base speed. So basically, we cannot go further than that in one cycle. And then we're going to have our fixtures, which is values that we're hard-code for now. And the first one is the direction. So that will be our f32, and that we're going to set it to -1. So 1 is counterclockwise, and -1 is clockwise. We're going to see why later. Then we're going to have our pivot point, which is the center of the ellipse. And for now, we're just going to put it at the dead center. And then we're going to have our radius, the x and the y, because we want to have it as an ellipse. 200 and 130, that's perfect. And then we're going to compute the next angle based on time for now. So let angle, the dir, multiplied by the base speed, by the time step, by the now, and then we're going to modulo that by our 360 divided by pi. So that works. There's probably better math here, but that works pretty well. And then we're going to compute the target xy. And first, we're going to have the x destination, which will be the radius by the angle cosinus, offset by the x pivot. Do the similar things on the y-axis. We're going to put sinus this time. And next, we're going to compute our distance. And the delta distance is going to be the difference between the origin and the destination. And here we need to make sure that, again, we are not overshooting. So we're going to compute the current distance, and then we're going to compute the distance ratio, make sure that we don't divide by 0, and that will allow us to compute the final xy. And here what we're saying is to say we don't want to overshoot. That is important again, because otherwise everything jingle around. So depending on the direction, we're going to take the max or the mean of one or the other, and then we're going to do the same thing for the y. And finally, rather to have our old code, we're going to have our translation x and y, and we're going to assign those two new values. Again, I like this style. And now we can see that the players spawn and they go in a kind of a circle. So that's kind of weird. So one of the things here, we have a bug, obviously, and it's a copy-paste bug. We forgot to do a command D. So that x should be a y. Now we run, and then everything go in ellipse. Pretty good. So now, because the things is based on time, the enemies that spawn in different times will snap to each other. So to be a little bit fancier on the enemy movement, we are going to create the concept of formation. A formation is one or more enemies will follow the same route. So first, let's do some refactoring. Let's go back on top. We're going to put in our enemy module into a folder, which is going to be enemy, drag and drop the file, rename it mod. So everything should compile the same and run exactly the same, like that. And now within our enemy module, we're going to create a submodule, which is going to be a module formation. We create formation.rs. And if we jump to it, and the first component will be our enemy formation component, which will be pair enemy. So that is going to be a struct formation, and it's going to have few properties. So first the start, which is the position, f32, f32, the radius, f32, f32, the pivot point, which is what we had before, and then we're also going to have the speed, and then we're going to have an angle that may change per tick, and we're going to see how later. So that is going to be a component that we're going to attach by enemy. And then after, we're going to have a resource, which is going to be our formation maker, like a formation factory. And so this resource will hold some state, and we'll have the current template, which will be the current template of the formation. So that could be an option of the formation. So the formation will be cloned for all of the members of the same formation. And then we're going to have a current members, which is the numbers of current enemies in this formation. We want to have the default. So the default here is pretty safe to be inferred. And then to make it convenient, we're going to have the formation clonable. Because again, we'll clone it per enemy. So now we're going to create our formation factory implementation, which is our formation maker. And that will be just a simple function, will be the make, and it will take a mute self because it will change the properties, and then it will take the win size because it needs to know where to place the enemy at the beginning. And they will be placed outside of the screen, but it needs to know the size of the screen. And the make will return the formation, obviously. So let's put a to-do for now, and we're going to go back to our main, and in our constant, in our game constant, we're going to add a constant for formation members max. So that will be the maximum numbers on any formation. And we're going to set it to 2 for now. Let's go back to our formation. We're going to match on the tuple, and that will be a match on the self of the current template, if we have a template or not. And then the second member of the tuple, if the current members are greater or equal to the formation max. So we have two cases. One, if we have a current template and we are still within the max members, meaning that we can return the clone of the template. And so that will be if we have some template and then second condition of the tuple is false, then we are just going to do a self current members. We're going to add 1, and then we're going to do the template clone. So super easy in this case. And then the second case is that when we need to create a new formation, and that happened that if this is a first formation, so no formation was created before, or if the previous, meaning the current formation, is full. So we need to create a new one. And so in this case is if we have none or anything, or if we have anything, or we are over the limit. And that will be our block. And that is where all the code will be. So again, big fan of the match tuple things. So we're going to put a to-do, such as we can press save without errors, and we're going to start coding this function. So first, we're going to get our random generator. Second, we're going to compute the start, x and y. So very similar to before, we're going to have the W span, the height span. So the x will be 50% chance, left or right. And then the y is going to be a range. And that will be the minus h from the h span. Then we want to make sure that we have f32. And that will be our start point. Now, we're going to compute the pivot point. And so the pivot is the center of the ellipse. So we are going to shadow the variables. We can reuse them. We don't need the other ones. So the rule is going to be a little bit different. It's going to be narrower. And that is the W span. And we're going to have the height span divided by 3 and plus 50. Put it a little bit higher. Should be a ratio or probably smarter ways to do it, but that works for now. And now we can compute our pivot point. That will be the range for the W span. And then we have the horizontal range, which starts at the middle and goes up. And that probably needs to be fine-tuned, but that will work for now. And now we're going to compute the radius. And so the radius will be our range. We're not going to be too fancy. It's going to be width to 80 to 150. And the height will be fixed at 100. Then we're going to compute the start angle. And so the start angle is from where the first pawn is to the center of the pivot. And so that is a math to do this. And we're going to use the attend to get this angle. Then we're going to set up the speed, which is going to be fixed for now, just the base speed. And now we have everything, so we can create the formation, and that will be our formation object. And now we can put all of these variables that we had above as such. So that again is the style I like. Once we have the formation, there's two things that need to happen. One, we need to store it as a template. So we're going to do self current template, and we're going to have our option and some formation clone. So we're storing the clone in this case as template. We're going to reset the members to 1. So now we know that there's one member. And then, whether to have our to-do, we're just returning our formation. And it's fine because the other one has been cloned for the template. So this one is okay to be moved. So if we go back on top, so we see that we have our formation component, which is created per enemy with our formation maker with the make method. So every time we need to spawn an enemy, we're going to call the make to get this formation information, such as we can display the enemy. Now, if we go to our enemy mode, we go to our plugin, build, and we're going to add an insert resource formation maker with the default. So that is important because we need to have the resource, the formation factory as a resource. And now every time we spawn an enemy, we're going to have the mute formation maker, which has to be obviously a res mute formation maker. And then when we're spawning, we don't need to compute the XY anymore. That will be done by the formation maker. So we just need to get the formation and the start X and Y. So we're going to do let formation maker make. We pass the window size, and then we're grabbing the XY from the start. So those will be F32, so they will copy. So that's fine. So we're not blocking them out. And then in our enemy movement system, we not only need the transform, but also the mutable formation. And we do need the mutable formation because we're going to change the angle at some point. So now in the iteration, we need to have the transform, mute formation. And now the speed could be formation.speed. The pivot will be formation.pivot. The radius, formation.radius. The direction, we are going to make it that if it comes from the left, that is going to be counterclockwise. And if it comes from the right, it will be clockwise. That works pretty well. And now at the angle, we just need to change that is a formation angle plus just going to be the direction multiplied by the speed. And then we're going to divide by the minimum radius of X or Y, multiply by pi divided by 2. So that works pretty well. Again, there might be better math, but this is working okay. So now that only thing that we want is we want to start rotating the formation angle only when the sprite is on or close to the ellipse. And so that will give us this nice little curve without having to do too much math. So what we do is to say if the distance is the max distance that we have before, and right now the ratio is 20, works pretty well, the angle of the formation, which is only for this enemy, is going to be updated. So next time it will start ticking around the ellipse. Otherwise, it stays where it is, and every time there's this nice approaching curve. And that, again, is just a technique to avoid math, actually. So now we're going to run it, and nothing is happening. And I think I know why. If we go back up, we have the transform and the formation there, but we didn't add the formation into our entity. In our enemy spawn system, we only have enemy and sprite size, and we don't have formation, even if we have created it over there. So they actually get spawned outside of the window, but they don't get moved. So we're going to insert formation, press save, click on run, and that's it. Both enemies are coming from the same formation. And if we shoot them, kind of, two others will come with another formation. And if we shoot one of them, the next one will have his own formation until we shoot the other one, and then both have the same formation. And that will be it for today. If you are still here, congratulations, you build a full game with Bevy. Until next one, happy coding.